All right, guys, welcome to our video on solving one and two step single variable linear equations. Now, here's the deal. Some of this stuff you probably have already seen. Maybe some of you have already mastered. You've got this locked down, but this is going to be pretty foundational for the rest of what we're going to do in Unit 2. So we want to make sure we're all on the same page. So let's get started. All right, what does it mean to solve an equation? Well, the word solve is a word you've probably heard many, many times before, but I found a lot of people have a hard time defining what does it mean to solve an equation, or what is a solution, right? So let's talk about that quickly. Just like in any good detective movie or TV show where they're doing police work, right? Solving something means finding the truth. And that's really no different with an equation. We're trying to find a value or values that will make the equation true, that will make the left-hand side equal to the right-hand side. So let's take a look at this example here. 3x equals 12, right? What would x have to be for this equation to be true? Well, I think it's pretty obvious. We can guess and check and figure out with our basic multiplication skills that x needs to be 4, because 3 times 4 is 12, and then 12 equals 12. This would be a true equation, 12 equals 12, which would mean that x equals 4 is the solution of the equation because it makes the equation true. This is going to be a big definition that we've got to have locked down our head because we're going to be coming back to it over and over again throughout the year to help us figure out methods and systems to solve different types of equations. So we can guess and check some equations as long as they're simple enough, but eventually we're going to have equations that will be too complex and too complicated for us to do that. So we need to develop a strategy or a system to be able to get those solutions, to be able to find what will make our equation true. All right, now let's look at what we did. We had 3x equals 12, and then when we were finished and we had our solution, we had x equals 4. So based off this, our strategy for solving our single variable in equations is to isolate the variable. All right, now it's going to get more complex than the example we see here, but this strategy will work to solve single variable linear equations. When we move on to different types of equations, we're going to need to come up with new systems. The nice thing, though, is our definition of what solving means and what solutions are will always remain the same. We're always trying to figure out what will it be that will make our equation true. All right, so let's start with one-step equations. What happens if we have a constant on the same side of the equation as our variable? So we have x and then plus 5. 5 is a completely separate term. Then the x, it's a constant. It has no variables. So how do we get x alone and get rid of the 5? Well, we can eliminate that constant by using its additive inverse. Now, this might be a word you've not heard before, so let's define it here. Additive inverses are numbers that when added equal 0. So positive 9 and negative 9 are additive inverses because 9 plus negative 9 is 0. So when we look at x plus 5 equals 12, we're going to use the additive inverse of positive 5, which is negative 5, to cancel out the 5. But with equations, we have to keep them balanced. So whatever we do to one side of an equation, we have to do to the other. So I subtract 5 on the left, I subtract 5 on the right, and x equals 7. All right, so what happens now if it's not a completely separate term or a constant that is on the same side as the variable, but we have what we call a coefficient? 8 and x are being multiplied by each other. 8 is a factor in that same term. So how do we get rid of the coefficient of x? Well, we're going to use the multiplicative inverse. All right, multiplicative inverses are numbers that when multiplied equal 1. So 7 times 1/7 equals 1. So 7 and 1/7 are multiplicative inverses. What I really want you to notice is what is in blue there. That dividing by the same number, dividing 7 by itself, is the same thing as multiplying 7 by its multiplicative inverse, or reciprocal, as you may have heard. So what we're going to do here to get rid of the coefficient of 8 is we're going to use the multiplicative inverse and divide by 8, which is the same thing as multiplying by 1 over 8. That's going to cancel out 8. But again, whatever we do to one side, we must do to the other. So we divide by 8, and x is going to equal 4. All right. This idea of whatever we do to one side, we have to do the other is actually a set of properties in mathematics called our properties of equality. All right. Again, we said doing the same thing to each side of the equation keeps it balanced. So the addition, subtraction, multiplication, and division properties of equality all are kind of saying the same idea that if I add, subtract, multiply, or divide to one side of an equation, I've got to do it on the other. We won't work a ton with these properties in algebra, but they'll become really important in geometry when you start working on proofs with your algebraic equations. All right, so here are some examples. What I want you to do is pause the video, try all 4 of these on your own, and then come back and start the video and check the answer. Ready, pause. All right, let's see how you did. Did you add 12 and get x equals 33, divide by 2 and get x equals 25, multiply by 5 and get x equals 35, and then multiply by 3 and get x equals 27? Well, I hope you did, but if you didn't, please write down your questions. If there's anything here that doesn't make sense, please write it down and make sure you're ready to ask about it in class. So let's move on now to two-step equations. So what happens when there is more than one number or value that we have to cancel out, that we have to eliminate to get our variable alone? So let's look at this example. We have a minus 7, so we have a constant of negative 7, and then we have a coefficient of 2, multiplication of 2 times x. So how do we get rid of the 2 and the negative 7? Well, we've got to determine order now. When we only had one thing to get rid of, there was no order. It was just that thing. But now we have to decide which do we get rid of first, the constant negative 7 or the coefficient of 2. The easy way to remember this is it always goes in the same order. Eliminate the constant first, then simplify the coefficient to 1. Eliminate the constant, simplify the coefficient to 1. That's going to be our order every time we come across the two-step equation here. So if we look, you can see we're going to eliminate the constant with its additive inverse of positive 7 and do it on both sides. Then we are going to divide by 2 with the multiplicative inverse and then do that on both sides, and we get x equals 10. But how do we really know that 10 is the solution? Remember, what does it mean to be a solution? That it's going to make that equation true when we substitute 10 back in for x. So let's check that. If I plug 10 in for x, I get 2 times 10 is 20. 20 minus 7 is 13. 13 equals 13. The equation is true. That tells me that 10 is the solution and that I've done the problem correctly there. This is the way you can check any single variable linear equation that you ever solve. Plug the solution back in, simplify each side of the equation. If you end up with a true equation, then your solution was correct. All right, so we got 4 more examples here. Again, I want you to pause the video and try these on your own and then come back and check your answers. Ready, pause. All right, let's see how we did here. All right, hopefully you got these solutions. And notice I did not show you any of the steps to do the work to get these answers. We want to see that on your notes. If all we see is answers, we know you're really not trying these problems on your own. You're just copying down what's in the notes. And in the end of the day, that's going to catch up with you when we get to tests and quizzes. So please be doing the work that we ask you to be doing in these videos. Well, that brings us to the end, and I think that's French for goodbye. But don't worry, it's not goodbye forever, just until the next video. We'll see you then.